Welcome back to the weekly Advanced Chemistry in the News, Winter Edition. I'm your host Tintin, and today we are going to discover how one recent discovery has challenged one of the most fundamental rules of chemistry. As we all learned before, carbon is a tetravalent atom, or in other words, it can form at most 4 covalent bonds with other atoms. This is because it has 4 valence electrons and it wants 4 more to fulfill the valence shell and be stable. However, nearly 2 years ago, German chemists from the Free University of Berlin created ion hexamethylbenzene, C12H18 2+, which has a carbon atom that forms an unprecedented 6 bonds with other carbon atoms, as you can see in the one with an arrow. In a normal C12H18 atom, the 6 carbon atoms form 3 double bonds and 3 single bonds with each other. They also have single bonds with the methyl groups CH3, so they have 4 covalent bonds and H valence electrons. Therefore, they are happy. In the C12H18 2+, besides the normal bonds of the 5 lower carbon atoms and the methyl group, this bizarre 6-bonded carbon atom on the top actually only has 4 bonds with the other carbon atoms, so the rule remains safe. In quantum chemistry, the valence bond theory states that a covalent bond is formed when the atomic orbitals overlap each other's. Here we can see that the upper carbon atom only has 3 overlaps with the lower ones, and 1 overlap with the CH3 above. In fact, through calculations regarding the atomic orbital bonding, the top carbon only has 0.54 bonds with the lower carbons, 0.54 times 5 other carbon atoms, plus 1 with the methyl group above is 3.7 bonds, which is not even 4, but for now, just simply remember that it has 4 bonds. Therefore, the carbon atoms are not completely bonded with each other. Their weak bonds contribute to the formation of the upright edges of the pyramid, which can optimize the orbital overlaps between the atoms. Let's see how this makes sense. Disregarding the CH3s, in a neutral C12H18, the carbons form 9 bonds, sharing 18 electrons. In the ion one, when it should lose 2 electrons, 5 lower carbons form 5 normal bonds. The upper carbon form 3, which sums up to 8, sharing 16 electrons. This discovery actually dated back to the 1970s, when German professor Hebke Hugeveen and his colleagues had theoretically predicted the 6-bonded carbon atom through calculations, but they failed to experiment and confirm it. In 2014, scientists attempted to formulate a 6-bonded carbon by manipulating a benzene or C6H6 atom, but for different reasons they calculated that it requires absolute zero, where there is no longer energy to achieve that, which is not possible. In 2017, the chemists in the Free University of Berlin came up with a technique to create a 6-bonded atom. They first used a peracid called MCPBA or benzoic acid BZOH to transform the regular C12H18 atom to the compound C12H18O. Then the chemists successfully dissolved C12H18O into a superacid mixture of HSO3F and SBF5 to create a mixture of C12H18 2+ and SBF6 2-. Although scientists haven't found a practical use of C12H18 2+ yet, the discovery has allowed them to gain a better insight into the bonding nature of carbon atoms, which are the building blocks of life in organic chemistry. To recap everything, when C12H18 loses 2 electrons, the carbon atoms will reformat into a hexagonal pyramid where the top carbon atoms share 4 bonds with 6 other carbon atoms, which still satisfy the tetravalence and octet rule. Thank you for listening. I hope you enjoyed the presentation.